Height, male, female. Missing age.
Weight.
Height, male, female.
Weight.
No,
Would you need weight?
I am trying to get the ideal body weight. Height, male, female, and age. Yes, I believe that's it. Wow, I can't believe I forgot that right there. Anyways, okay, let's go on to the next thing. The flow rate, how fast do I want to deliver this tidal volume? If a person is in distress, they want the help right away, I'm going to give them a faster flow rate. Frequency is how many times a minute will I deliver this tidal volume. PEEP and FiO2 was the pressure, the positive and expiratory pressure. So that's the pressure that's left inside of the patient's lungs at all times while they're on the ventilator. And then FiO2, fraction of inspired oxygen. So here you have your rate with the F, indicated by the F. There's your tidal volume. Okay, this inspiratory time, that kind of, it correlates with the flow rate. Okay. And then you have your FiO2, and you have your PEEP. Okay, so the way all these ventilators, whether it's invasive or non-invasive, it's going to be separated in 3 categories. It's how do I want to ventilate the patient? Okay, what is the patient actually doing up on top? And then I get an inside look of what's taking place in the lungs. So this is not just for cool graphics. This is, we actually look at this and we analyze it and we fine-tune the patient's ventilation, and we can touch it and turn it and adjust it based on what we see as an inside look of how we're ventilating the lungs. So for example, here I put a rate, a assist control rate of 10, and the patient is doing a rate of 10. Thus, the patient is getting controlled breaths. Okay? If the patient was getting, if I put 10 here, and the patient has 20, then 10 out of those 20 breaths are going to be controlled, and the other 10, that's going to be an A for assisted. So no matter what, whether the patient starts the breath or doesn't start the breath, the patient will get a tidal volume of 500 with this inspiratory time or flow rate, this FiO2, and this PEEP. And another term you probably have heard is pressure support. Right? Pressure support is any time a patient is breathing spontaneously. Now notice the ventilator settings for non-invasive ventilation. You'll see they are very similar. Tidal volume, frequency, IPAP, EPAP, and FiO2. Okay, so here you know what the tidal volume is, the rate. IPAP is inspiratory positive airway pressure, and EPAP is expiratory. EPAP is the same as saying PEEP, only it's on a non-invasive ventilator. That's it. So IPAP, let me grab it really quick.
This is non-invasive, right? He said.
IPAP is going to be a value that you're going to touch and turn. There's the IPAP right there. I'm going to touch it and turn it to whatever number I want. IPAP is equivalent to if you were helping a person breathe with this type of mask and you squeeze it, that's IPAP. If I want to squeeze them, and let's just say this is 7, just like that. If my squeezing the bag at a pressure of 7 is not sufficient for the patient and their chest is barely rising, then I'm going to do 14. I'm going to give them a higher pressure, right? So the amount of IPAP is going to determine how much tidal volume, how much you're pushing into the patient's lungs. EPAP is just that pressure that's left in the lungs at the end of exhalation. And so these two are always having to do with oxygenation. So oxygenation, ventilation.
Yeah.
Yes.
I'm just gonna ask, they're moving more and more towards non-invasive. right, as much as they can.
Yes, as much as they can, they will. And the reason is because the studies show that of your COPD patients, CHF patients, if you put them on BiPAP, 3 out of 4 patients, you can prevent them from being intubated if you try BiPAP or non-invasive. You'll also see that used interchangeably, BiPAP and non-invasive, same thing, okay? So they'll always try it first because the success rate is very good. Okay, and that's because you can do basically everything here that you would do on a ventilated patient. Okay? You could optimize their ventilation, their assistance with that. All right, there's 2 ways of ventilating. Once you have them on that mask, there's 2 ways of ventilating them. One is ST, which stands for spontaneous time, and then the other way is CPAP. So spontaneous time is the same as if you were to say AC on the other, on this one, if they were ventilated, if they were intubated. That is the person that you want to control, right? They're sick, so I want to give them more controlled breathing. Same thing here, you want to put them on ST. Everybody else here on CPAP, this is going to be, CPAP is going to be for, if it's not for congestive heart failure patients, CHF patients, it's going to be with a patient who has sleep apnea. So you're just using it just to hold the airways open when they're asleep, and you don't want the airway to collapse and obstruct their airway. That's it. But if I do ST, spontaneous time, X amount of time is going to occur, and I'm going to give them a breath with X amount of volume, or I could dial in IPAP, EPAP on every breath. And that's how BiPAP began. BiPAP in the ER, we would, if a person had a hard time breathing, we would maybe give them a nebulizer treatment. We would put that nebulizer treatment here, then put the mask on the patient, and then every time they wanted a breath, we'd give them a breath with their nebulizer, like this. But coordinating it was difficult because patients breathing very fast and in distress, and then you put a mask on them and they feel like you're trying to suffocate them, right? So they went from doing this because it worked to now putting a patient on non-invasive ventilation with a mask, same concept. There's the IPAP, and then the EPAP is part of it, and we'd be giving them 100% oxygen. All right, so this is just a different ventilator screen, so it doesn't matter which ventilator you see at your hospital, it's the exact same thing that, like I told you. You set parameters in one location, you find out what the patient is doing in another one, and then you also have a list of alarms that let you know what is the problem. The ventilators, by and far, if the studies have shown that ventilators will not fail, it's always a user error. I think the percentage is like less than 2% of some issue being related to a mechanical issue with the ventilator. So here's some of the terminology that you might have heard: mandatory or controlled. Okay, the ventilator controls everything. Assisted means that the patient only triggers the breath, but the ventilator controls everything thereafter, right? And then spontaneous. The patient is the one that's in full control. So remember that one mode that I told you, remember AC, assist control, right? If the patient wants to trigger, he gets a breath. If he doesn't want to trigger because he's too sick and he's just apneic or sedated or paralyzed, then he gets controlled. And then the patient that's about to be extubated, he's spontaneous. He's breathing on his own. And you would see that on all these ventilators, they let you know, is it assist, or is it controlled, or in this case, synchronized? Or, I'm sorry, not synchronized, spontaneous, sorry. So those are your 3 top modes there. This is just showing you assist control, okay? So just telling you that the rate is only as a backup, right? So I dialed in a rate of 10, but if the patient wants to get 20, he gets 20. Okay, so it's only as a backup. If he stops breathing, he's getting his backup of 10. And so notice here, I have, let's say a backup rate of 10. So if the patient wants to take a breath, they could. and I would see it on my graphs. I could see that there's a dip. The patient makes a negative effort, and the patient gets a breath. Okay, if the patient does not take a breath, then it becomes a controlled breath. There is no dip in the pressure. It's just the ventilator is ready to deliver. If the patient takes no efforts, then every breath is a controlled. There's no dip in pressure there. And so that would let me know it's a patient-triggered breath. That's when you know if the patient's really sick or not. If the ventilator is controlling them, or if they're assisting the ventilator, or if they're just doing spontaneous. So all the settings here are the same. Show you a couple of short videos. I don't know why it's not working right now. Let me go over time. I think it's just slow. I think it will start. Hold on.
So that's the volume control mode for a patient that would be happening. Pressure and flow, we do not see any patient efforts being taken. And in the event that the patient starts waking up, you will begin to see some triggering. In this case, the ventilator is set on pressure triggering. And right there, you can see the pressure trigger effort. And another one prior to the machine breath. The machine will respond to every patient breath. And in this case, the patient stopped breathing, fell back to sleep. And if the patient starts breathing and is anxious and takes a lot of breaths in a row, the rate will increase.
Okay, then you have that second one, the one where the patient's getting better. Patient's getting better, you don't have to fully control them. Patient breathes spontaneous breaths in between some mandatory breaths, right? That's the intermittent part. And the mandatory breaths are delivered just like you would anybody else, a tidal volume, flow rate, PEEP, and FiO2. And if the patient wants to breathe on their own, the ventilator does not ignore that. It allows them to have their own spontaneous breaths, and we assist them with some extra pressure support. Okay, so pressure support is the difference between IPAP and EPAP. Okay, so if I want a pressure support of 5, then that's just a little bit of assistance. Or pressure support of 10, a lot more assistance. There's a picture of SIMV. Here's the mandatory breaths, the big ones obviously, but in between the big ones, the person can breathe spontaneously, and I'm helping them out with some pressure support. So the settings are, everything's the same, except now I've added pressure support to those spontaneous breaths. So you know that that's the case because if you were to look at the volume, the mandatory breaths are delivering a bigger amount of volume versus the smaller amount of volume for somebody to breathe on their own. But they're getting better. And I'm just using some control and allowing the patient to do some of their own breathing. Then the last one is spontaneous, just letting the patient control everything. So they determine how big of a breath they take or how shallow of a breath or even how fast. The only thing I do is I support their breathing, their spontaneous breaths with pressure support. So notice this is this tidal volume that they're giving, or the breath that they're getting, it's whatever they determine. If patient starts breathing more shallow, then the next one will be, you'll see them, that they're dropping as well.